Okay, so when we're looking at these ones, a couple of things we need to decide and talk about first is where our endpoints are. So we have breaks here, 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 and here. So this range here is going to be from -7, and we can equal that point, that's fine, to, it's going to be -3. So x less than or equal to -3. So then this one right here, it's going to be from -3 to 1, so -3 less than or equal to, and it's fine if we put both of them are less than or equal to. Really, you could just pick one and say, hey, this one's not going to be able to equal it. It really doesn't matter because they're connected at that point. So x and less than or equal to 1. And then we'll look at this range, depending on how you do it. If you say it's an absolute value, so I'll put abs, so this would be absolute. If you're doing it that way, then you would say 1 to 7. If you did it where you broke it up individually, then this one's going to be 1 to 4. And this one's going to be 4 to 7. So just depends on how you do it. I'll show you both ways. So when we're looking at this one, the first thing we can do is kind of figure out our slope here. So f of x, and we're going to start writing them out across here. So we're going to have, our slope is going to be, looks like up 1 over 2, up 1 over 2. And remember, in order to figure out our intersection point, we can just continue the trend. So it'll be up 1 over 2, up 1 over, or we go up 1 over 2, but we can find the point actually in between here. We're going up a half every time. So it's going to be at -0.5. So we're going to say 1/2. It's a positive slope. We're going up. 1/2 x minus 0.5. And this is going to be true from -7, so equal to x to -3. So that's part of it. So then the next one, our slope is 0, or yeah, we don't have a slope. So we're not going to have an x, but we are at -2. So -2 is going to be our value. So -2, and then we put our distance. So -3 less than or equal to x, which is less than or equal to 1. So I'm going to do this first as if we were to break it up into 2 different lines, and then I'll show you what it would look like if we were to do it as the absolute value. So for this one, our slope, we're going up 1 over 1, up 1 over 1. So we would be able to write x. And then our intersection point, we just keep on going back to the y. So down 1 over 1, or down 1 back 1. And that's going to put us at 1, 2, 3, -3. So -3. And that's going to be from 1 less than or equal to x less than or equal to 4. So then this last part here, it has a down 1 over 1, so it's a -x. And then we are going to just follow back to where it would intersect. So back 1 up 1, back 1 up 1, back 1 up 1, back 1 up 1. Looks like it's at 5. So then we would just write 4 less than or equal to x, which is less than or equal to 7. So that is one way to write it. The other way you could write it, so I'm going to just clump those and say or, we could also do this as an absolute value. So for the absolute value, we know that we have an x. So we moved it to the right 4 spaces from where it originally would be at the origin. So we're going to do -4. And then we also went up 1. So +1. The other thing, though, is we flipped it over the x-axis, so we need to put a negative sign out front. So then we'd also put it's true from 1 less than or equal to x less than or equal to 7. So that's another way you could do it. That's the absolute value version. This is if we were to break it up in different lines. It's a little bit shorter if you do it this way, and you can recognize it. Also, we're using our transformation skills that we've been working on. So this is a good way to try and work through that. Okay, on the next one, the exploratory challenge 2, it says the graph y equals f of x of a piecewise function is shown. So it gives us the domain and it also gives us the range. Not super critical, but it's still important to have there. So it says mark and identify 4 strategic points helpful in sketching the graph. So when we're looking at this 4 strategic points, we should be looking at the beginning, if we're going left to right, the end, and then where it's breaking. So right here would be a good point to look at, and this one as well. So this one is at 3, comma 1. This one is at -1, comma 1. This one's at -5, -1. And this one right here is at 5, 3. So those are going to be points that are important as we go forward and start to change this graph. So for this next one, it says sketch the graph of y equals 2 f of x and state the domain and range of the transform function. So if we are multiplying this number out here, then or with the number outside, then what we're doing is we're multiplying our answer or our y value. So right here, when we look at these points, we're going to be changing where our y value is. It's effectively like multiplying all of those by 2. So if we originally had -5, -1, our new point is going to be -5, -2, because we multiplied this one by 2. So we could also think of it as x times, or comma, 2y, since we're multiplying 2 on that side. So then the next one, our other point was -1, 1. The new would be -1, 2. And then if we had 3, 1, the new would be 3, 2. Then for the next one, we have 5, 3. The new would be 5, 6. So all we did was we just multiplied our y value by 2. So the nice part is, then once we graph these points, we just draw lines between them. So for this one, -5, -2, put a point there. Then -1, 2. And then 3, 2. And then we have 5, 6. So 5, and then up to 6. And then from that, we can draw our lines. Let's see, I have something I can actually use. So you can use a straight edge. It's not really important, but you'll get a good idea of the slope and how that changes. So draw a line across. And one more. And there's our graph. So if we're comparing it to the original graph, you can tell a couple things fairly quickly. The slope is a lot steeper on all these that actually have a slope. And it's kind of more spread out in the y direction. So it says to state the domain and the range. So our domain, that's our x values. So our x values still go from -5 to 5. So we have -5 less than or equal to x less than or equal to 5. So that is our domain. Our range, which is our y values, that has changed. So when we look here, we went from -1 to 3. Now we're going -2 to 6. So y less than or equal to 6. So now our range has increased. It's actually not quite. It has doubled from what it was before. So our range has increased and become larger. So a horizontal scaling. So this time now we're going to use a horizontal scaling with a factor of 1/2 of the graph. And so now we have f of 2x. So sketch the graph and state the domain and range again. How can you use the points from part A to help you identify? So I kind of talked about it up here. I'm going to write out the points here for you, just kind of write them back down. I want you to practice on this one, see if you can figure out which one's changing, if it's X or it's Y this time. So take time, practice that, and then come back and look for the answer. So there are the points. Give it a shot. Okay, so this one on the inside, now we're actually multiplying those by a half. So now we're going to be changing the factor, but we're multiplying this by a half. Even though it has a 2 out front, in order to get the same y value, we're multiplying by a half. That's our scale factor. So new. So we're going to multiply -5 by a half, so it'll be -2.5, comma, -1. So our new for this one would be -0.51. Our new for 3 is going to be 1.51. They didn't like to put even numbers on here. So our new for this one is going to be 2.53. So we did absolutely nothing to our y values. They stay the same, but our horizontal scale is now shrinking because we're multiplying by a factor of a half. So if you remember the first page, that means that it's going to be shrinking, getting smaller. Even though it's a 2 out there, it's kind of deceptive. So when we're graphing this, -2.5, so -2.5, -1. So right there. Then we have -0.5, we're going to be at 1. 1.5 is at 1 as well. And 2.5 is at 3. 2.5 right there. So if I get out my straight edge again. Got a couple. So then we can draw the lines between them. Okay, and there we go. So now we have our lines, and if you look, our graph definitely shrunk from what it was before. Here was our domain, just how far it went. Now it's a lot smaller. So if we're comparing our two graphs from earlier, spread out, it's a bigger picture, but even then you can definitely tell that it shrunk. So it wants to state the domain. So the domain, if we remember, it's our x. And so now we go from -2.5, that's our smallest, less than or equal to x, and our largest is 2.5, so it's less than or equal to 2.5. Our range, this was not affected at all. So now, that's our y, we have -1, less than or equal to y, less than or equal to 3. So our range has not changed, but our domain has. Exact opposite of here. So this is where you can really start to see the difference between the horizontal shift and the vertical scaling. So horizontal scaling change and the vertical scaling change.